What we have here is a typical exam question where we're given 4 functions and 8 graphs and we're supposed to match them. It's a really typical Algebra 2 pre-calc exam question. This particular video clip is the 3rd part of a 4-part theory on how to graph and match those kind of functions. Let's get started. What I have here are standardized steps on how to find or graph any of those functions we're given. Step number 1, we're looking for holes in the denominator where the function is not defined. So for example, this one and this one here, when we set the denominator equal to 0, x is going to be at minus and plus 1. And that's where the function breaks off because the function is not defined for this case. And for this one over here, x equal to 1, the function is not defined. The reason we want to find the holes is because then we can examine the vertical asymptotes of the function. What happens when the function close to the hole where the function is not defined? Typically, function, of course, blows up on one end and goes positive infinity and negative infinity on the other side. And that's why the function is not defined. After finding the vertical asymptotes, we're going to move on to finding horizontal asymptotes. That's when the x is either really large or really small. What happens to the function? What's the behavior of the function? And from there, the very last step is we're going to look for special values, and that's when x function cross x-axis or y-axis and or y-axis. So let's go through this series of 4 videos, and we're going to follow exactly the 4 steps, and let's have some fun with this. Alright, so let's go back one step at a time. Here's the function we're given. Denominator is undefined when x equal to 1, so that's what we call the holes. X equal to 1 has undefined point. Now right around the holes, we're going to plug 2 points right around from the left and from the right to see what behavior of the function looks like. That is called a vertical asymptotes. Okay, so as you can see, x is approached positive infinity from one end and negative from the other end. That's why this is called a hole, because the function is not defined. A function breaks up, basically. After examining the vertical asymptotes, we're going to take a look at horizontal asymptotes. That's just a fancy word to say when x is really big or really small, our absolute value is a big number, what happens to the function. Now, this function is particular interesting, if we rewrite this a little bit, or you can just plug 1,000 or 10,000 value for x, and you can see the same thing. X and x minus 1 kind of approaches 1 as x to be a really big number. So the function actually approaches to y equal to x, which is a straight line. And this is interesting, doesn't happen all the time, but for this particular function, hx, as x approach positive or minus infinity, the function becomes a linear function. And so as this so far looks like it's going to be number 2 on the graph. One last thing to do for the special value, the function will not cross x-axis, or actually does. If we value to 0 for the function, we can see 0, 0, the origin is a point on the graph. So there's a big, huge clue. We can pretty much eliminate this graph, so is this one, and so is this one, because 0, 0 is not on the graph so far for those graphs. And all we have left is 2 and 4. As you can see, since there's only one vertical holes, asymptotes, when x equal to 1, so the graph has to be number 2 for h of x. Let's do a quick summary. So here's a quick summary. Our special point 0, 0 is right over here, and that's from step number 4. When we looked at the step 1 and 2, where the holes are, where x equal to 1, we evaluated a little bit over 1.0001 and 0.999. We can see the function breaks. One goes to negative infinity, and the other one goes to positive infinity. So the red is from step 1 and 2, where we had the vertical asymptote behavior. And the blue ones are from the horizontal behavior. When x is really, really big, positive and negative, the function follows y equal to x as a straight line. So that's the function x h of x. The graph is number 2. Well, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment or share this video or hit the like button. Together we can make math easy again. Have a confident day.